Okay, this is IM2 and we are on page 175 and we are doing proof and problem number 4. So we are given that line QD is congruent to line UA. Line QD is congruent to line UA. Those are both labeled for us. Angle QDA is congruent to angle UAD. Angle QDA is congruent to UAD, also labeled for us. We need to prove that triangle QDA is congruent to triangle UAD. While this seems like a very complicated and overlapping figure, this is actually a really simple proof. We already know everything we need to know. So just to clarify, I am going to go ahead and draw these two triangles out separately so that we can see them. All right, my drawings are terrible, but you can use your imagination. All right, so we know that this angle and this angle, that's D and A. This is D and A again. We know that this angle and this angle are congruent. We know that this line and this line are congruent. So let's write that out. So QD is congruent to UA. Those are both lines, and this is given. We know that angle QDA is congruent to angle UAD. Again, this is given. There's one more. We either need another angle or we need another line. We don't know anything about, this is Q, this is U. We don't know anything about these two angles. We don't know anything about these two lines. However, this line down here and this line down here is this line here. And we can note that they're actually the same line. DA is congruent to DA. So DA is congruent to, and I'm going to just call it DA again for simplicity. Why do we know that? Well, because they're the same line, and the math word for that is the reflective property of congruency. I abbreviated, you can too. So if we have a side and we have an angle and we have a side, then we can use the proof. We can say that triangle QDA is congruent to triangle UAD, and the reason is side, angle, side. And that's our proof.